So in this video, we're going to look at moments. So a moment is a measure of the turning effect of a force on a rigid body. So what that essentially means is we're talking about a rigid body and how that force will cause it to turn. So that moment is dependent on the size of the force, and in particular, we'll look at the perpendicular component of the force. We'll explain what that means in just a bit. And also the distance between the point of application of the force and the axis of rotation. So this is all about the force of turning, about the force of, and how it affects the rotation of a rigid body. So we've got an example here. We have a rigid body, and we see the distance from this fixed point here at the center, and the edge is going to be 6 meters. And we're going to consider a couple of different situations. The first of these situations we're going to consider is we're going to consider a force being applied right on the end of that rigid body. So force, we'll call that, we'll say 5 newtons. Now, if that force is being applied right on the end of that rigid body, what it will cause to happen is this point will be fixed and the rigid body will turn in this direction. So it will turn in a clockwise direction. Now, to calculate what we call the moment around this rotation, the moment about that point, the moment is simply equal to the force times the distance. And when we're talking about that force, we're talking in particular about the force acting perpendicular to our rigid body. So in this instance, our moment is simply going to be the force, which is 5, multiplied by the distance, which is 6, and that is going to give us 30. Now, since we've multiplied a force by a distance, force is measured in newtons, distance measured in meters, so our moment has a unit of 30 Newton meters, and because we are specifically turning in this direction, we need to specify that our moment is 30 Newton meters clockwise. If we consider now a second example, so we're going to consider and look at the same rigid body, the same distance from its fixed point, but we are going to change ever so slightly. We're going to change ever so slightly the way that force is being applied. So we've got a force applied, we'll keep that force as 5 newtons. However, this time, rather than being applied perpendicular to our rigid body, our force is being applied at an angle. And let's just, for example, say that angle is 40 degrees. So our moment is going to be the force times the distance. However, we need to consider, rather than it just being this 5, we need to consider the component of that force, which is acting in the direction perpendicular to the rigid body. And the way we're going to do that is we're going to consider forming a right angle triangle. So if I think about my rigid body facing this way, the component of my force, which is in the perpendicular direction, is this here. And then this part here would be in the parallel direction. So I could just include that. So we've got this component of the force acting in the parallel direction. So the bit that is perpendicular, if I just for the moment call that x, then what I can do, I can use my right angle trigonometry. I've got x being the opposite side here. So I know that sine 40 is equal to the opposite x over the hypotenuse 5. So sine 40 is equal to x over 5, which means x is equal to 5 sine 40. So now, if I want to calculate my moment, the moment is equal to the component of the force in the perpendicular direction. So that was 5 sine 40 being multiplied by the distance at the mean of application of the force and the axis of rotation. So that remains as 6. So in our calculator, we can go 5 sine 40 being multiplied by 6. And then that is going to give me, we'll go to one decimal place. So we've got 19.2. So 19.3 if we're rounding, Newton meters. And again, if we're considering the fact that that would cause our rigid body to rotate in this direction, that would still be clockwise. At the end of this video, thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.